Hey folks, I hope you're all having a great day. Welcome to the 135th episode of YFTT, Tech Talks for Engineers by Engineers. And I'm Premkumar, Technical Evangelist at Yugabyte. I've been here for about 2.5 years now. Today we have with us Naitik, who is a Principal Solutions Architect. He's been designing so different schemas and solutions for our customers, and he's going to talk about follower reads and read replicas in both YSQL and YSQL. Over to you, Naitik.
Thank you, Prem. Hi, I'm Naitik Shah, part of the customer success and field team here at Yugabyte. And today's topic is follower reads and read replica, right? So let's dive right in. Uh, just want to make sure, yeah, you're able to see my screen. All right. So follower reads and read replicas. We'll have a demo for follower reads as well as a part of the agenda, and then we'll leave some time towards the end for any questions.
Cool.
All right. So first things first, why and when do we need follower reads? Right. So essentially, when we have global applications, multiple region deployments, um, where we have application and the database deployed across multiple regions. We want to make sure that the reads for the application are closer to where the data is, right, and not just read from the tablet leaders. So that's where we need follower reads. We can get better read performance, achieve low latency, right? And essentially, we can tune some of the data staleness configuration as well. So we'll look at all of these key points in the upcoming slides as we go through. All right, so let's look at, first of all, the default behavior, right, in Yugabyte. So as you can see here, we have multiple regions: US West, US Central, and US East. And then we have application deployed in each region as well. And then we have three nodes in the cluster. So these, the pink or the red circles that you see here, they're the database nodes. And the app is trying to get the data, and the default behavior for both reads and writes in Yugabyte is being consistent, right? So it would, when the app tries to read, it reads from the tablet leader. And the tablet leader here is in Central. So the app in US Central is able to read that locally. But when the apps from US East and US West, they try to read the same data, um, they have to go through US Central and read from the leader, right? So that's where that's what the default behavior is. And here, the apps in both US East and West would incur cross-region latency, right? So here it would be 30 milliseconds and 40 milliseconds respectively. All right. So how to get a lower latency in this kind of a situation is what follower reads is gonna help us solve, right? So with follower reads, we could have the same exact deployment as far as the database nodes and the application as well deployed across the regions. However, the thing here is that the app is able to read. Um, um, the follower reads. We haven't set this up yet. This is still the same example, right? Showing you that the app
Exactly.
is
That's what I was selecting.
trying to read from the US East, where the tablet leader is, and the app in US West is incurring 60 millisecond latency, and then the app in the US Central, in this case, is going through 30 millisecond cross region latency.
That's because reading from the leaders gives you the latest consistent data.
Mm-hmm.
Yep.
Yeah,
Cool. Sounds
right. Yeah, thank you, Prem. So yeah, I think so. When we set up follower reads, we are able to achieve low read latency, right? So the app here on the US West is able to read the one of the copies, which is essentially a follower of the same shard or tablet, and it's able to read that locally. So the access time is like 2 milliseconds, right? And then the same happens for the app in US Central as well. However, the only thing to keep in mind here is the stale reads, right? So there is some amount of stale data that would be read. It's not the consistent data that you would have at the tablet leader, right? But that's a trade-off that follower reads provides. Lower read latency response times. The only trade-off here is you might be reading stale data in this case. All right, what happens if there is a failover, right? So um, assume that one of the zone or node fails, then the app does a follower read from the next closest region, right? So in this case, the next closest region for US West is US Central, and that's where the app is going to go to and get the um, data from, right? So in this case, instead of going across to the east and incurring 60 millisecond latency, the app is able to read from a closer region, which is US Central, and access it within lower response time, right? 40 milliseconds. Um, all right. So overall, just to give a quick like summary of the follower reads here, um, essentially, yes, the behavior is we are able to read from the replicas. The only caveat there is we read stale data. The reads are closer, to the app, right? So essentially, if the app is in a specific region, you're able to read it locally. So read from closer regions. And of course, the main goal here is to achieve low latency, right? So this is a summary, and then feel free if you have any questions, you can post it in the chat, and we'll take a look at how we configure follower reads next, right? Okay. So these follower reads can be essentially used. I'll just give a quick thing here as far as uh, what kind of applications would be able to use follower reads, right? So applications wherein you're not trying to read the data right after you write, and then there's no need for latest data for the app. Mostly interactive applications, offline operations, right? Where data doesn't change much. Um, so some of the examples would be like the movie database or a books information or social interaction database, and things like that, right? So wherever you need low latency and there's not much data that's changing, you could essentially enable follower reads for any of those apps.
One thing I want to point out on it. So this is only for reads, as the name says. For writes, even though the applications on US East and US West, if they are the offline apps, they try to write, the writes will actually go to the US Central where the leader is located. So the writes always go to the leader. That's how we guarantee consistency. So,
Yep, perfect. Yep. Thanks, Prem, yeah, for calling that out. So writes are not affected essentially when follower reads feature is enabled, right? So
correct.
they would still go to leaders. Perfect. Okay. So now let's look at how to configure follow reads. And we have two APIs within Yugabyte, as you all know, YSQL, which is our Postgres API. And we have a couple of these G flags or settings, right, that we can enable at both at the G flag level or at the universe level, as well as at the session level, right? So we'll take a look at both of these. So the first one is the G flag itself, YB underscore read underscore from underscore followers, right? So the default behavior in any universe is set to false. So follower reads are not enabled by default, as we saw earlier. So if you want to enable, you can set this to true. And then the other parameter here is essentially controlling the data staleness, right? So um, this is a fixed staleness setting, meaning we will always read from whatever is the current time and the setting here, right? So current time minus the staleness setting that you have. So and we'll look at this example in the demo. And the default setting for this is 30 seconds. Now, for YSQL, which is our Cassandra API, you can enable follower reads by setting consistency level to 1, right? And this is at the driver level. There's no other, you know, cluster level configuration needed in order to use follower reads within the YSQL API. And we'll look at this example as well in our demo. So there are two things here as well. One is start to read uh, your your operations, right, using consistency level of 1, and then the other setting controls the staleness, right? And again, this is by default 60 seconds. This is bounded staleness, meaning we would pick the most recent value between the current time and the value here, right? So whatever is the most recent, meaning between the current time and the last 60 seconds, whatever would be the recent value, we would provide that, right? So so that's how the YSQL API setting works. Any questions or anything that you want to add in here before we move?
I mean, no questions so far.
Okay.
But one thing we have failed to mention is that even though this is a best effort attempt to read from the local followers, in case, depending upon the settings, the data is not available according to the staleness defined, the reads will be redirected to the leaders.
Lead.
So that's one
Yep.
thing that you
Perfect.
have to remember. So configuring the staleness flags is very critical. So the defaults are pretty good. So yeah,
Yep, exactly. Yeah. So if and when essentially the follower does not respond within the staleness time, for example, for any reason, then that read would be redirected to the tablet leader. Yep, perfect. Thank you for calling that out. That's very important. So let's move to the demo. And I'm gonna switch screens here. So I'll go first of all. So I have a three-node cluster here. I'll start with the YSQL demo. So essentially, setting the consistency level to 1 would get us um, the follow reads enabled. So I'm running the default behavior here. So I have a three-node cluster. I just started some workload. It's connecting to all the three nodes. So um, we should start to see some read traffic here, right? And yeah, we do see it. So if you look at yeah, if you look at the reads here, we see about 1400 operations for a read, and they're all going to a single node N3 because that's where the tablet leader is, right?
so
And
what's the workload here, Naitik?
so the workload is a very simple. So I have a table and it's trying to just read, like it's a select star query
Okay.
for yeah a specific key, right? And here, like everything is going to N3, which is, and I
Okay.
can show the exact configuration as well. But what I want to highlight here is that a single node is participating in the reads or for the read traffic here.
So is the read on a single key by any chance, or a set of keys? What's the read look like?
Yeah, so I think it's a random set of um, uh,
Oh, but there are only three nodes, and then the tab. There is only three tablets. Okay, that's fine. Okay, it doesn't matter.
that's
Now
yeah.
I got it. Yeah, three
Yeah.
tablets.
So essentially, this is
One
the
single.
uh, query, and it keeps rotating. These keys, right? So
Okay.
for a specific shard, right? But essentially, it's just doing a select star, and if you see the consistency, it's local quorum. I mean, anyways, for Yugabyte reads and writes are always by default consistent, right? So no matter whatever consistency level we set here, anything other than one, for reads, it's always going to be consistent,
Yes.
right? All right. So now I'll show you the example for follower reads, and you could see the difference here. The consistency level that I'm setting here is one, instead of a local quorum, or even if you don't set any consistency level, like I mentioned before, it's by default consistent. But in this case, we want the follower reads to be enabled for YCQL, and for that reason, we are setting it to one. And it's the same exact query that we had earlier. The only difference here is the consistency level. And I'm gonna run that follower reads workload now. And we should see the difference here. Instead of like a single node serving all the reads from the tablet leader, we should see even the followers participate in the read volume. You should see that in a sec. Okay, there we go. So now, instead of close to 1400 or 1500 reads on a single node N3, now we see N3 is only serving like 1/3 of the original traffic.
Nice. Very nice. Very nice.
So now we have reads coming on the followers as well. So N1, N2, N3. So essentially, we are
But
able
the
to
client application is connected to which node? All the three nodes here?
all the three
How's
nodes.
all the
Correct.
three nodes?
So
Okay. All right.
yeah. So since we are using the smart driver, right, the YCQL driver,
Okay.
essentially it connects to like all the three nodes, right? It
Oh,
establishes the connection to
cool.
all the
Very
nodes in
cool.
the system. Yeah. Um, so yeah, this is the YCQL demo, and I'll use the same cluster for now for switching to the YSQL demo as well.
So these are all the default bounded staleness setting.
Yes, correct. This is the default staleness setting. Yes, for YCQL. All right. So make sure go to the default. All right, the read traffic has stopped. Right, I'm going to use this other terminal for. All right, so now we are connected to the YSQL API, right, which is our Postgres interface. And we're going to create a very simple table here. So this is the YSQL demo that I want to show for follower reads. And I'm just going to create a very simple table. So table T with, K as the primary key, and then there's another column
Visa
here.
value basically.
Yeah, so key and value. And then I'm just inserting a data select star. We see the data, right? Now let's uh, enable, or let's set the YB read from followers at the session level here. And then there's another sort of transaction as well. So I'm going to run these, and I'm going to explain, what am I doing here. Um, so here I'm setting the YB follower reads enabled to true, and then I'm starting a transaction, which is essentially a read-only transaction, trying to read the same data and commit, and I'm able to do that, right? Even within this read-only transaction and even outside the transaction, it's the same value. Now, coming, so let's look at the staleness property here, right? That way we can get a better understanding of how the follow reads would work in SQL. So I'm going to set the transaction setting to read write in this case. And then let's try to read the value here. It's still the same v1, and now we're going to try and update this value, right, to, let's say, v1 plus 1, right, in terms of the value. All right, and now we're going to wait for a few seconds, approximately like 10 seconds, and then run another update, which is essentially on the value v1 plus 2, right? And now I'm again gonna wait for a few seconds before I run the select here. Um, all right. So I see the latest value here. Now we see this because the transaction is set to read and both read and write. So now I want to
Could you
set
could you
this.
hi- could you highlight that statement? Could you highlight that statement? Read right. Yeah,
Yeah, it's this
that's the
one.
one. Yeah.
Now let's set this to. Oops, I think I ran all the statements, but yeah. So essentially, wanted to set this to read only mode, right? And then we set follow read set to true, and then we perform a select, and that essentially gets well. In this case, I think we missed the time, right, in terms of when we did the update versus when we are running it. It has to be very close um, in terms of the updates that we run. So essentially, what I wanted to show you is even if we run so once we set the staleness, let's say, to 5 seconds, and when we run a select here, it's gonna show us a value which was there for this v column 5 seconds before, right? And then same for here, like if I go back 15 seconds, what was the value 15 seconds before, right? But I can set this to a very high value just to give you an example.
Exactly.
um, and then like just we should be able to see at least like, yeah, just 200 in this case to be sure. um, okay, I
That's
think
because
that,
you're in the same transaction. You have not come out of the transaction.
yeah. uh, so I think we should still be able to read this, say. Yeah, so there we go. So we set this to a higher value. I think 100. I think we were past 100 seconds as well. That's why
Really?
it's
Oh, okay.
only showing the latest value here. But if I go back further, right, instead of 100 seconds, I'm going back, let's say, 200 seconds, and I see the original value. Original meaning the value that we had inserted, right? V1 is the value.
That's cool.
So essentially, yeah, I hope that explains it. Um, yeah, you wanted to add something to it here? Or
So right now you had connected to one specific node. Which node did you connect to? Would you know? Did you
yeah,
connect to the leader or?
so 162. Yes, that is the master leader.
That's the master leader, not
Yes,
the tablet leader.
not the
So
tablet.
the thing
Yes, yeah.
is, the behavior would be the same if you connect to the leader tablet leader also, because that's how it works. So that's why in middle of where Naitik had connected to, the behavior would be the same. It would the leader would also be considered as a uh, tablet follower to for this particular in this particular case. All right, cool. We
Yep.
have about 6 minutes left. Could we take a look at the read replicas quickly?
Yep. Sure. Sounds good. All right. So let me switch back to the presentation here. All right.
Yeah,
Let's cover the read replicas a bit here in terms of the slides. So again, when and why would we use read replicas? Very similar scenarios as far as local reads, low latency reads, global applications. Um, as we had explained in the follower reads, the writes still go to the leaders. The only thing here, or the only difference here is um, there are a couple of differences, right? So essentially, one is the read replicas do not take part in the Raft consensus. They're completely separate. And for that reason, you could even set a separate replication factor from the primary, right? So read replica would be essentially just a cheap faraway setup, right, as we have here. And we'll take a look at the diagrams. I think that's gonna
Help you
help
understand.
better. Yeah. So let's consider this original scenario, right? For read replicas, let's say the app is
No,
in
you
the
don't have read replicas yet. This is the primary cluster. So
correct. So this is the primary cluster, and the app is trying to connect to US East. That's where the tablet leader is, and we also have followers in US Central and West. Right. So primary cluster is in the US. Um, so you have it's a standard global database, right? So and here in this kind of scenario, we are assuming that generally reads are typically more than your write volume. So you're essentially having a higher ratio for reads versus writes. um, there are low writes overall. And let's look at how we set up the read replica, right? So now let's say your application decides to expand in the Europe, right? It's not just in the US. And initially your European users are trying to come and access the data across the ocean, because your data set is in the US regions. So they typically would see higher uh, of course both read and write latency, right? But in our product, we have assumed that yeah, we don't have too many writes happening. So yeah, for writes you would still incur higher latency, but you can at least um, improve your read latency performance by setting up read replica. Now how would we set up read replica? Is something like this, right? So we have set up a read replica here in this case in Europe, and this is gonna there's no need to set up an entire cluster per se, right? Which is essentially a higher cost. We are just setting up a read replica, which is quite low in terms of the TCO, right? And you don't have to move the followers. In the case where a region failure in the US happens, the US users will, in case of that, right, US users would face very high latency, right? So you don't want to partition your data that way. Um, so in this case, you're essentially your European users are able to access the local reads, and they don't have to go to the primary cluster. Instead, they can just access it from the EU West region here. Right? Anything you want to add, Prem? Anything
oh,
that I've,
is that the last slide for you?
I think, yeah. So we have a couple of things, right? So one thing I wanted to cover is we could set, a different replication factor, right?
Okay.
Different from the primary, because as I mentioned, the writes when there are writes happening or going to the primary, the read replicas do not participate in the raft consensus, right? So this is whenever a write is happening in the primary, the replication to the read replica happens asynchronously, right? So it's happening behind the scenes. It does not again wait for any acknowledgement, or doesn't participate in the consensus. Um, so here in this case, you can even set up replication factor, which is different from the primary. It could be even, right? So there is a lot of flexibility that you can have at a very comparatively cheaper cost, right? To set up read replicas overall. And one thing I want to highlight again, since this is async, there is possibility that you might be reading stale data, right? Slightly stale data when you're trying to read it from the read replicas.
So just one thing is reading from read replicas is very, very similar to reading from followers that Naitik explained earlier. It's the same setting, YB read from followers equal to true, and then you have to set the transaction to be read only. So the key thing from this particular slide diagrams is that there is an application on Europe side which does the YB read from follower setting to read from the data on the follow read replica in Europe cluster. That's the key difference here, and so that's it.
Yeah, that's perfect. Yeah, thank you for that. I think, yeah, this is just a summary slide where we are explaining, how the overall architecture would be for read replicas. Essentially, you would have a primary, and then here is the read replica, because you see all the dotted lines here. So essentially, there's no leader here. You can have a different set of RF, and the local application can access the data at a pretty low read latency in this case. Yep.
Some of the interesting use cases for read replicas is, for say, you have a banking application, and then you have globally distributed users, and say in this particular example, US and Europe. And for your US Europe users, if they want to see the transaction history, which is practically a read only, which is not being modified, and even if slight delay is okay, you can have your European users access their banking history, transaction history at a much lower latency than. But when they want to do an actual transaction, they still have to go to the US cluster, because that's where the leader primary cluster is, and that's where the writes go into. Other thing that I want to point out is failure. So the key thing about failure is, if one of the regions in the US fails, it will fail over within the US alone, and your write latency won't be affected because of that. So that is where the significant part of the read replicas not being part of the raft protocol comes in. So it doesn't fail over to Europe. So if it actually fails over to Europe, that means that your US users will have to, where most of users are located, will have to face a high latency by having your writes being replicated to Europe. That doesn't happen in the case of read replicas. That's why we make sure that ensure that your failover happens within the US region. That's why Naitik has three replicas within Europe. Sorry, within US, and read
Yes.
replicas in. That's it. That's
Yep. Perfect. Yeah.
uh,
For covering that.
Any closing comments? That's a good presentation. I think. Any closing comments?
Nope, I think so. That's pretty much it. We have a couple of blogs. All the demos that we went through, we have a pretty good documentation, and thanks to Prem and the Yugabyte team, and we pretty much have follower reads both for YCQL and SQL in our documentation, and then we have a few blogs that could be very informative as well. So we have a blog from Prem that essentially covers the best practices for a multi-region database deployment. I think there are 7 best practices that Prem has covered. Check that out.
I think
And then
that
we
was
also
also an
have,
YFTT. I think me and Kanan did it a while back. So,
awesome. Yeah, that's great. Uh, and you could see the recorded YFTT sessions as well, as Prem mentioned, if you want to watch the previously recorded ones. And then we have another blog from one of our Yugabyte team members, Satish, and that is how data replication works in YugabyteDB, right? And it essentially covers a lot of features that Yugabyte provides: follower reads, read replicas, X cluster, right? So I think it covers both synchronous and
and
asynchronous replication in Yugabyte. But yeah, that's pretty much it. Any questions? Um,
thanks. I think I don't see any questions. We can close this out. So
okay.
if you have any questions, ask us on Slack and check out our source code on GitHub. Thank you, folks. Have a great day.